If you want to learn about Spring Data 4, you're in the right place. My name is Chris Bono. I'm a software engineer on the Spring team at Broadcom. And I spend my days working on Spring Data, Spring Pulsar, and Spring gRPC. Today we're going to go over Spring Data, and really it's going to be, we have 45 minutes. We're going to go over what are the new features in Spring Data 3.5, and then we'll also talk about what's coming up in Spring Data 4. Cool. Disclaimer, no, I'm kidding, I'm not going to read it all. So the agenda is really Spring Data, we'll go start with Spring Data 3.5 and we'll talk about differences there, and then and that's already available. Spring Data 4.0 is what's coming out. It's planned, we can't say the date, but it's whenever all the other things are coming out with Spring Boot and that next version line. And if you're familiar with Spring Data, there's a bunch of sub-projects underneath Spring Data umbrella where different data access technologies. There's definitely more than what's on this list, and so we're covering just the high points of what's been added. And so, yeah, Spring Data, we'll talk about Mongo first. Mongo and Cassandra, both the big feature in 3.5 is, one more thing real quick. You'll notice that we say Spring Data 3.5, but then you'll say MongoDB 4.5. So in a perfect world, versions would line up, but they're not necessarily the same version number. So in Spring Data MongoDB 4.5 we've added vector search support, as well as, and same for Cassandra. Another interesting piece for Mongo is they've added encryption throughout their whole basically their product suite. So we have support for that. And Spring Data JPA, we've had some improvements in the DTO projections. We'll show an example there. We'll mention that in Spring Data Relational, JDBC, and R2DBC, we've added sequence support. We don't really have a slide for that one though. All right, so I'm sure everybody's heard of vector search and AI and Gen AI and things of this nature. So vector, we've introduced a type called vector, and it's not the old Java util vector from very long ago. It's to encapsulate basically a multi-dimensional point in space. And the reason that we've created this type is that because all the different data stores that support vector search represent it slightly different. Ultimately, it's usually floats, but for instance, Mongo represents it with a class called binary vector. So we've introduced this vector type to abstract that out a way, to insulate from changes, and also to have a common way to create a vector when you're doing search. Here you can see, instead, rather than just say new float array, you can use static methods like vector of, and then there's Mongo vector is a Spring Data. It's a Spring Data class that extends vector and has support for some Mongo specifics. Let's see. And so the way that MongoDB makes vector search available is through they have an aggregation basically called vector search. And what we do is we have a vector search operation, and the first part there says search, and what you're searching is the index. The index, there's a trick here, is that that's the cosine index is, we could have called it foo index. It's, you have to get your collection and say, hey, I'm setting this up for vector search. And then once you set it up for vector search, you can query it. Here we'd say, you say what your path is, and the vector in this operation here is the vector that you're trying to search against. Those are your search terms. Before we'd say where name equals Chris, and now we say where vector equals a vector like this. We set 10 limit, and then the search type is approximate nearest neighbor. That means whenever you're around this point, the closer it is, the more likely it is that it's a hit. And then what you do is you just take your Mongo template and you call aggregate, you pass in that aggregation, and it comes back with some search results. Another really interesting piece that MongoDB has added to their driver is encryption. And so they have support for client-side field encryption. That's where whenever you send stuff across the wire to the server or to the client, that it'll be encrypted. And then once you say that this field's encrypted though, the trick is, okay, how do I query that? Because now it's encrypted. Name is Chris, doesn't work anymore. And so queryable encryption allows you to say, okay, these fields are encrypted, and I want to be able to query this still. And so that gives the hint to the driver to know how to decrypt it whenever it's running the query. There's support range and equality queries, schema support. That's the collection creation. I was talking, very similar to the vector search. So this is what an example looks like. So we'd have our person entity, and you see here you can say, okay, at encrypted, at queryable. This basically will encrypt the SSN field, still allow you to query it on equality, and so on and so forth. The age is encrypted, but it's now you can now query it through a range. And so you can see by nothing's free, right? So you can see that you have to go do this and set this up ahead of time. So you're going to encrypt your data, but if you want to query it, you have to also specify how you're going to query it. Let's see. Yep. And so now we go back to, that's all I wanted to cover for MongoDB for Spring Data 3.5. So vector search for Apache Cassandra looks similar, same concepts, but the way that it's done is slightly different when you go to query. We'll also talk about, there's also a baseline upgrade of Cassandra 5 in the Spring Data 3.5. Something that's been really cool that's added to Cassandra 5 is storage attached indexes. And so if you've used Cassandra, it's really like it had the same feel when I said, well, if you're going to set this up for encryption, you have to know ahead of time. So you have to know how you're going to query your columns ahead of time in Cassandra. And that's through an index. You have to set an index up on the column. Storage attached indexes makes that, they're superior to the Cassandra's built-in indexes, and they also enable vector search. That's really that was kind of what they were born for, but it turns out that those are really the recommended way. You can add indexes to things with less downsides than you would previously. So here we have an example where we had our entity right here, called it comments. We set up an ID field and a comment field, and you'll notice there's this new vector field. Vector is, again, the data type that we introduced at the beginning. And you'll say, okay, this is a vector type, and it is SAI indexed. And so at that point, we should be able to do a vector search against it. Here's the result. Comment search. You're going to take a comment and then return the similarity. So, this looked very similar as before. You create your search vector. I'm looking for this vector, and you'll say, I want to select the columns, comment vector, where similarity, we have this little Fluent API on the right-hand side where you can specify, okay, the similarity to this vector cosigned as similarity. And now you just push it through your typical query and template as you're used to doing if you've done querying without vector search. So at the last steps, it starts looking very much like what you're used to using if you use Spring Data Cassandra. So Spring JPA 3.5, there's been some refinements and bug fixes in the JPQL parsers and Fluent. We won't really cover that. The big thing that we're going to show is the DTO constructor expressions. And so if you're familiar with the projection, so I'd say select from user. I'm going to get back a list of users. And a lot of times we don't want a list of users. We want some DTO or some data transfer object, a user info, user excerpt, I think is what we call it here. And so you can see we have this user repository, and the query is select. This is the constructor projection capability. So you say select a new user excerpt. You can see it's pretty terse, the syntax. So we refined it a little bit more, and now you can just say select u.firstname, u.lastname, and then another step there, select u from user. So it becomes easier to do projections without having to have a bunch of field by field by field specification. And so, okay, so that's Spring Data 3.5. And then we're going through this fast. I want to make sure we have time for questions at the end. So Spring Data 4, the big pieces are a baseline upgrade, and this is any Spring talk you've seen today. It's the next generation. Everybody's going to say, "Yep, the baseline upgrade, Framework 5, Boot 4." JSpecify, our whole portfolio has been updated to support these things. Kotlin 2.0, Jakarta EE. JSpecify, if you haven't seen it or used it, I feel like over the last 10 years, you go to one code base and it's JSR 305 and it's nullable. And is it Spring nullable or is it JSR 305? It's never been real standard. It's never been standardized. So JSpecify kind of answers that, and it's a standard set of annotations for Java static analysis. It's not fun to go re-instrument all your code with it, but once you have it there, it's pretty nice. And the other piece of it, there's buy-in from the whole community. So all the tooling's there. I used to be able to just have JSR 305 nullability things and just say, oh, okay, yeah, I see the warnings, but I'm busy. I got other things to do. Now you can't compile. Now you can't build. It's in there. You have to fix it. I mean, you can ignore it. We won't do that. Okay. Ahead of time repositories. So this is really the big thing that's been added in 4.0. And so, how many of y'all are familiar with AOT processing and Spring or Spring Boot? No, nobody's familiar with it. So, have y'all heard? Who's heard of GraalVM? Native images. Okay, so that AOT processing is ahead of time processing, and so the whole concept is with native images in land of Java, right? And Spring specifically, Spring is dynamic. You set up your configuration. We do a lot of things at runtime. We do a lot of reflection at runtime. It's expensive, and people say, "Why does it take so long to start up? This is ridiculous. Why is it taking so much memory? We want it faster. We want it smaller." And so Graal, and there's a bunch of other JVM technologies that have made the improvements over the last few years great. The whole assumption with it is that we trade in a dynamic open world at runtime is where we go and figure out what things are to run. What we do with AOT processing and just in general is we have a closed world solution where, okay, here's your set of configuration, here's your set of this, you know this ahead of time, so we do that statically at build time. Spring AOT specifically, you don't have to use GraalVM with Spring AOT. They complement each other, and Spring AOT, what it does is we go do that same static upfront processing, and what we generate is, what comes out the other side is statically generated code. And that alone, with less reflection, makes things start up faster. And so that's the simplest way to explain it. So almost any of the Spring projects, they all support AOT in some form or fashion, some more than others. And so Spring Data already had support for AOT. There's some basic things you can do. You can set some hints files and say, okay, this is a reflection hint, so it's going to run slower. Or, you can do some things to play nice, but we were thinking, what can we do to make it even, how can we add more AOT to Spring Data? And so the area that we've added to now is your repositories. And so what happens now is the user repository we're looking at before will go through at build time, and it goes through that same AOT. It gets into the Spring AOT hook, generates some code, and it makes it faster. But one of the coolest things it also does is, if you're familiar with debugging Spring Data queries, it's okay. You step in and you're like, okay, I'm in this interceptor, and then I'm in this proxy, and then I found it some method down here, but what is it? I don't even know what it's executing. I just want to debug my query, right? And so a side effect of these ahead-of-time repositories is that they're static code, and so now you can just actually jump into the method and actually debug your code very easily. We'll see. There's some screenshots to show you. And we also we spit out this repository.json file so that tools can use it to do cool things. We'll show a picture of IntelliJ doing some cool stuff here in a second. Okay. And then we'll mention JDBC, composite ID support's been added, and there's some Fluent API refinements for MongoDB and Cassandra. I think we might talk about that if we have time. JPA, another interesting piece with JPA is that before Spring Data 4, we did a lot of criteria-based queries in JPA. They're slow. And so we don't do any more criteria queries. I think when we do query by example, we still do them, but everything's using JPQL now under the hood. And it gives you the good performance no matter what you're doing, derived queries. And so we have some graphs to show some metrics on that. Okay, let's start off with, we're gonna go through, this is a repository query method, maybe user repository, and we have count by last name. So what the magic of Spring Data is that it goes and takes this and does some magic, and this naming convention, count by last name, ultimately does a SQL query. Okay. And so this is what we talked about, introspection and debugging, the problem, like why is it so hard? And this is that interceptor thing I was talking about at the proxy. I'm like, okay, cool, I'm set to debug, and I'm what? And where? And then, and if you've done it long enough, you know what this is doing, and you know where to put the breakpoint in, and it's not 13 levels up, it's actually way down here in this little magic place to put it. So if we go here, with AOT repositories, slides got kind of older, I left them out of kind of order. Really what you need to do is set this property, Spring AOT repositories enabled true. Or if you're using GrawVM native, it'll do that for you. There's the Gradle or Maven plugin will do that. But we talked about introspecting and debugging and how it's better. Tooling support, yeah. I was jumping ahead of the slides. So here's some of that generated code. So whenever we have Spring AOT enabled and we go and we say Maven package, Gradle build, you can go look under your target. I wish we were having fun earlier today, and I was wishing that I had done just a big, small enough demo so that we could have looked in the target directory and pulled right in here. It would have been just so easy to do. Okay, so this is what comes out the other side of the build, right? So you have now an entity manager, and this is generated code. And the beauty of it is there's our count by last name. Or you can see the query string, right? You can just step through the entity manager. At this part, you're just playing in JPA land with the entity manager. And if you can put a breakpoint on the line that says query, you'll probably find your problem. Okay. So we talked about the startup performance. This is, you can see this is regular, no AOT, just dynamic Spring running. 5-second startup, I think it's startup performance. AOT, not the repository support, just the stuff we already had built in. And, an improvement, 9%. And then AOT repositories, 11%. It sounds like I sound excited about it, like it's going to be down to 1,300. It looks like it's just a small improvement, but that's the way whenever you add AOT to something, you get a big hit doing something simple, but then if you want to start getting it faster and faster, you got to add more things. Okay, so now with the JPA repository startup performance, again, regular AOT and then AOT repositories, it's an improvement over in the right direction. Let's see. Yeah, okay. So this is the other piece that if you were to look in our target directory after the build, we generate this repository.json file. And as you can see, it makes it so that tools can get at it and say things like this. Okay, you can see, the target directory is right here. So AOT optimization, that's our user repository source, but you can see we're just clicking right there and it gives us options, either navigate to, let me go here, that is small, navigate to AutoWire, no. The one is navigate to, where's the repositories? AOT implementation, is the one that would take us down to that user-generated code. Okay. Yeah, but so the point is once you're in your editor, and now I can just click on this repository query method, it goes into the generated code, put your breakpoint, and you're good to go. And I mean, for me, if anybody asks, like, why should I use Spring? Why should I use that? For me, it's always about developer velocity and experience. I know if I do whatever technology I'm going to use, if I'm going to use MongoDB or Pulsar or whatever, I get the same kind of things, and I have that. It makes things move faster for me. Okay, so yeah, the application must run in AOT mode or be an native image. We talked about that. And if you're interested in more AOT processing stuff, there's the Spring Boot docs, and Spring has a really good, very good explanation of it that'll be more clear than mine was, and then you'll say, oh, okay, I get it. So yeah, required AOT processing. One thing to be aware of is with AOT, things get out of sync because that closed world, and I don't know how many times I've done this or still do it, that I go and we're debugging something, and then you go and run it through the build, test it. It's not fixed yet, so come over here and do something else, and then it's not fixed yet. But the problem was, like, I didn't go through the native build, and so you got to be sure to remember to reprocess these dynamic things so your changes get picked up. Okay, so it is available. AOT repositories right now are available in Spring Data JPA, and it says Hibernate only because also R2DBC and JDBC are now under, I think, Spring Data Relational. But the point of JPA is available now. MongoDB AOT repositories are available now, and we're working on the other modules as well. Hopefully we'll have more support for other modules before we release. Let's see. Okay. Spring Data JPA 4. Let's see. Again, a baseline upgrade, but for JPA. Hibernate 7. I did mention the query derivation. We're using JPQL under the hood instead of Criteria API. There's been some specifications improvements. So specification is I update specification, delete specifications, and it's a fluent API so that you can operate on your data. We're not going to really talk about query enhanced selectors here, but it's available. And same for JPQL parsers. These are just improvements. Okay, so this is Spring Data JPA 3.5 with Hibernate, and that's Spring Data JPA 3.5. That was not Spring Data 4, Spring Data 3.5. So you can see with just JPQL straight entity manager access, you have 650 queries per second, and then about 100 criteria queries per second. So it's slow. Now, as you can see, by getting rid of criteria API, using the criteria API behind the scenes, everything's starting to look more like the JPQL performance with the entity manager, at query, derived queries. Things are behaving where we would expect them to be. Let's see. So yeah, missing update support and broken delete support. Yeah, the broken delete support. I'm not gonna. It's an interesting bug that's been kind of coming back and forth over the years, but it's improved. Let's say that, and it's not broken any longer. And so we'll do one example. We'll have an example of an update specification. Also, we have composition of predicates now, so you can say where name. Yeah, there's an example as well. We can combine predicates when we're doing these specs. And so you can think of specification as just a fluent API. Specification, to me, the term is always a kind of an ambiguous thing. Okay, so let's look at an example. So I have a predicate, and it's where the users has first name, Oliver, and that's the composition part. User has last name, Gierke. And then here's where we use it. We say, okay, let's create an update specification for the user. We get this triplicate of information. This tuple comes in with a root update and a criteria builder. Then what we do is we say, okay, update.set the last name to drop home, where, and then the predicate. And so you can see this is update user table where first name Oliver, last name Gierke, set last name equal to dropbone. And yeah. And then you just can pass that into your repository. Update the last name. Yep. Update the last name. Yeah, you pass the specification into the update method, and then it goes and executes it. Similarly, there's similarly something for delete, and that's what I was kind of alluding to. And so a couple things with MongoDB 5.0 and Cassandra 5.0. There's more result mapping variants that have been added and some fluent API refinements. And what that looks like is Yeah, like for the result mapping, you can, first of all, Spring Data Commons is now is in the process of replacing application event listeners with more like entity callbacks. So those are available for most of the modules. And that's where you can say on before save, on after save, and do some logic there rather than try to hook into the application listeners. And type-based, yeah, this is where you can set your I think this is meaning type-based. Okay, so you can say now list of person projection or list of persons, or you can use a converter to get back the actual query type. There's also the Fluent API is basically there's more ways to access the result mapping, the result set as you're setting up your Fluent chain. You can, for instance, here in this case, you can say map, and then you get the actual native document. That's going to be the MongoDB document and the reader, and then you can do some mapping, do whatever you like there. So those are the refinements that have been added, as well as you can actually get the raw query result if you want to do that. Let's see. Oh, yeah. There's one more thing. So we'll come back to vector search, and then before you saw how we did the vector searches, we would get it, and we'd have to using the whatever the template is, Mongo or Cassandra, and then we'd have to chain up and say, okay, query this, use the vector, and there was a terse. The usage of it is not as clean as. That's why we like repositories, is because we can do magic like search top 5 by embedding within and pass in the vector and pass in the score. And then what happens under the hood is basically the things that we talked about earlier. So here's how you would use it. You set up your vector, and then here, repository, search top 5, and then you get, I thought it was going to show results. But again, it gives us a familiar programming model declaratively. It also encapsulates us from the store variant. So vector search is different with Mongo. Vector just search is different with Cassandra, et cetera, et cetera. Everybody's got their own specific flavor of how they're doing indexing and how they're, and this is no different with Spring Data. It's nice to, we operate at the top at the abstraction layer as much as we can, but there's no doubt that eventually you have to drop down and do something with the particular technology. But this abstraction gives us the variant, it lets us stay up there at one level and then have similarities. The similarity here is the concept from vector search. We try to have some normalization of it, whether it's Mongo or whether it's Cassandra. Let's see. Yeah, and this is available today with JPA, and MongoDB, and Cassandra. I don't know why. Spring Data 2025 1.0 and 4. Maybe that's when it's available right now. It's already out. That's when it was available. That's the first time that it became available, I guess. And we're also exploring Neo4j, Elasticsearch. I know JDBC is in progress right now. It was almost done, and so we were hoping to have it, but yeah, soon. Couchbase as well, but the Neo4j module and Elasticsearch module it's not maintained specifically by Spring. That's a commercial product, but we work with them. They work with us. Let's see. Okay. Why did it go so fast? It took so much longer when I was doing it. I'm like, I have to talk really fast. I just talked really fast. Cool. So yeah, we have time now. Excellent. Time for questions.
Anything new in Spring Data JPA?
Anything new in Spring Data JPA? Sequence support, composite IDs. I feel like I skipped something. Bear with me. We're going to do the whole presentation. We can do it again. We have time. Backwards. We could create we could do an AOT repository right now. If y'all, it's not my computer. This is demos on Wednesday. Let me just go back to here. At sequence support and composite IDs is something I can think of right offhand. Yeah.
What does that composite ID support look like? Just adding another ID annotation on it, or one together?
Yeah. At the end of the day, you will have multiple annotations and let them compose into other ones. Jans is our Spring Data JDBC. He's the JDBC guy, and so he is the one that does all things JDBC. Yeah. I think there's afterwards. I'll point you to the. I'll look up any preview docs that we have and point you to it if you like. Yeah. Yep.
How do you guys plan to implement native support for Spring Data JDBC? I mean, for JPA, it's quite obvious, but for JDBC, they can generate SQL. Like,
Did you say AOT repositories?
yes.
Yeah, it's a lot. Yeah, I don't like I don't like implementing. So just if you don't have to go instrument your code with AOT code, we do, right? And so what that looks like is it can be intrusive because we have this hook at the Spring AOT support. There's a callback and a hook that you can get into and say AOT is about to do this. Would you like to generate some code? Would you like to get involved with this? And if you're a developer and you say, we want you to go to the Spring Data JDBC AOT, you're like, oh no, because the variants, you're writing code, you're using code to write code, and we use Java Poet behind the scenes, and it's not the worst API, but I've been doing this a while, and I feel like I can code a bit, and even when I get in there, I'm just like, where am I? And I'm not saying, this is not me saying don't use AOT. It's you're gonna hate your life. I'm saying whenever you have to instrument the code the one time, it can be problematic. How deep are you gonna go? And that's also like the performance. Like there's some things you can do and add a hints file to some of your dynamic pieces, and you'll get an immediate improvement in performance. But the deeper you want to peel that onion, the more messy it can get, and the more complicated it can get. Yeah, I don't know. Jans is doing it. I can't wait to get back on Monday and see where he's at with it. So yeah.
So AOT repositories enable like default when doing it. You see that changing from time to time.
Probably not. It's just so defaults change slowly in Spring in general, and it's if you do at configuration, the default should be proxy bean methods equals false, but it's true. And this is just a little detail that where if you're familiar with what it is, it's so that you can do this bad spaghetti code type things inside your configuration, have one method chain into another, and that's hard to debug, but it's still the default because it's one of these things that's there. AOTs, some people don't want it's just it'll be a hard default to change probably. Yeah. Yep. That's it. Yeah. There you go.